Ladies and gentlemen, Step Up International by Nicholas. Today we talk matters gas laws, straight to the point. So we have three things that are very important when discussing gas laws. We have the thermometer for measuring temperature. We have the pressure gauge for measuring pressure, and we have a heat source that provides heat energy. And we have a container to help us see the variation in volume and how it relates to pressure. Let's begin. We will begin by injecting some gas particles within our container, and then we shall hold temperature constant. Can you tell us which law is this one? With a count of 3, 2, 1. Yes, you are right. It is Boyle's law. Boyle's law compares volume and pressure. So I want us to see when we reduce volume at that level, the pressure is at roughly 19 to 20 atmospheres. When we change the volume, when we increase the volume, we have seen the pressure comes to around 8 to 9, meaning when the volume is increased, pressure has reduced. It means volume of a fixed mass of gas is inversely proportional to pressure. Inject some air particles, and this time round, we want to compare volume and temperature, meaning we shall put the pressure constant. Someone tell us which law is this one? On a count of 3, 2, and 1. You're right, it is Charles' law. Charles' law compares volume and temperature at a constant pressure. So let's see what happens when we change the temperature. Currently, the temperature is at 300 Kelvin, pressure is 11.6 atmospheres. Let's heat and see what happens next. Let's heat. As we continue heating, volume also need to increase. So volume is directly proportional to temperature. I want us to keep volume constant and see what happens. Volume is now constant. Volume is constant. Let's change the temperature. Currently, the pressure is at 11.5 atmospheres. We are maintaining the volume. As you increase temperature, what is happening to pressure? We can see that increase in temperature increases the pressure. Collision between particles and the walls of the container has increased. Therefore, increase in temperature causes increase in pressure. So, we begin with Boyle's law. And we say Boyle's law, temperature is constant. Therefore, we discovered that volume is inversely proportional to pressure. If we remove the proportionality sign, we can say that V is equal to K over P, where K is a constant. This therefore follows that K is equal to Vp. So for a given pair of setups, we say V1 P1 is given to V2 P2. And we said in Charles, pressure is constant. Therefore, we compared volume and temperature and we discovered that volume is directly proportional to temperature. So if we remove the proportionality sign, introduce a constant, so we can say K is equal to V over T. And if you have a comparison of two medium, maintaining Charles' law, we shall have V1 over T1 is equal to V2 over T2. Let's go to what we call now the pressure law. In pressure law, we maintain volume. We discovered that pressure was directly we discovered that pressure was directly proportional to temperature. We talk of absolute temperature. Therefore, if we introduce the constant kT, K can give us P over T. For a compared medium, we shall have P1 over T1 is equal to P2 over T2. The combined gas law, I'm going to use the Boyle's law and the Charles law. Remember, volume is inversely proportional to pressure, and the same volume is directly proportional to temperature. So if we combine these two statements, we can have, therefore, that volume is directly proportional to temperature, but inversely proportional to pressure. If we introduce constant to replace constant of the proportionality sign, we shall have V is equal to KT all over P. So if we have K alone, we can say K is equal to Vp over T. For a compared medium, we always say that V1 P1 over T1 is the same as V2 P2 over T2. Let's talk of ideal gas equation. In A levels, we introduce the ideal gas equation and it emanates from the combined gas law. Already we know, we have seen above, that K is equal to Vp all over T. If we cross multiply, we shall find that Vp is equal to Kt. In ideal gas situation, we replace this K with the amount of gas and a constant. So we shall have Vp is equal to Nr, represent the amount of gas. R represents how much energy a mole absorbs at any increase in temperature. Is the equation for ideal gas. Now I want us to go step ahead and now apply them in typical questions. Gas occupies volume of 200 centimeters cube at a pressure of 100 kilopascals and a temperature of 27 degrees Celsius. The gas is compressed until the pressure becomes 150 kilopascal and temperature becomes 57 degrees Celsius. Find the new volume of the gas. Change the temperatures to Kelvin first of all. 27 degrees, you have to add 273. That one, you will get 300 Kelvin. Then we have 57 degrees plus 273. We shall have 330 Kelvin. P1 V1 over T1 is equal to P2 V2 over T2. Remember, we are supposed to find the second volume. Now, you can either choose to make it the subject or just substitute in the value and get what times V2 all over T2, which is 330. 147 centimeters cube. That is how we solve it. Don't forget the formula and don't forget to change the temperature to absolute, meaning to Kelvin. Second question. A container holds 0.50 moles of gas at a temperature of 10 Kelvin. The pressure of the gas is 1.2 times 10 power 5 pascals. Find the volume occupied by the gas. Take R to be 8.31 joules per moles per Kelvin. That PV is equal to nRT. So we have V is equal to nRT over P. N is the mole, the number of moles, 0.50 times R, the constant, 8.31 times the temperature in Kelvin, that is 300. All this divided by the pressure. Pressure we have is 1.2 times 10 power 5 means meters cube. This is how we apply the concepts that we have learned on gas laws. For this and many more concepts or related ideas, don't hesitate to hit us in our social media handles. Till next time, enjoy.